Hello students, this is Vijay Ushir. In the last lecture, we have studied about the applications of adsorption, and in that we have studied the first and most important application, that is the catalysis, means the role of adsorbent in the process of catalysis. So we know that the process of catalysis means what is the role of catalyst? Catalyst is the substance which increases the speed of reaction. So by using the adsorbent material as a catalyst, they increases the speed of reaction. So that was we have studied in the first application, that is a catalysis. So in this lecture we will study the second application, that is purification of water. So we know that naturally occurring water mainly contains the soluble and insoluble impurities. Means the naturally occurring water has two types of impurities, that is some are soluble and some are insoluble impurities. And which are these? So insoluble impurities are mainly clay, sand and vegetable matter, and the soluble impurities are salts of metals like sodium, calcium, magnesium, iron. Means they are easily soluble, that is these are the ions, therefore they are easily soluble and categorized as soluble impurities. But the clay, vegetables and sand, these are insoluble, therefore they are categorized as insoluble impurities in the water. So the insoluble impurities in water are removed by the filtration. So by simple filtration process, if we do the filtration, then the insoluble impurities remains on the filter paper or whatever the filter we are using. So the insoluble impurities like clay, sand, vegetables, they can be easily removed from the water by the filtration technique. And the filtered water is then passed through finely divided charcoal packed into column. Means the filter water, then after removal of insoluble impurities, that filtered water is passed through the finely divided charcoal. We have studied that finely divided charcoal, that is an activated charcoal, which is acting as a good adsorbent and which is packed into column. Means it is packed into a column by chromatographic technique. So the charcoal, we know that charcoal is a good adsorbent and it adsorbs the soluble impurities together with the vegetable and other coloring matter. Means the role of activated charcoal, that is a good adsorbent which can absorb the soluble impurities together with the vegetable and other coloring matter. And the presence of soluble impurities makes the water hard because of in the water, due to the soluble impurities like sodium, calcium and magnesium, the hardness of water is increases, and hardness of water is mainly due to the calcium 2 plus ions, magnesium 2 plus ions, and some natural silicates like zeolites, that is example is Na2, Al2, Si2O8. So this is a sodium silicate, and some synthetic organic long chain compounds called as a resins. They have tendency to adsorb H plus ions and OH minus ions. Means the presence of soluble impurities makes the water hard, and due to which ions? Due to calcium 2 plus and magnesium 2 plus ions. And some natural silicates like zeolites, that is Na2, Al2, Si2O8, and some synthetic organic long chain compounds called as the resins, they have high tendency to adsorb H plus ions and also the OH minus ions. And the cation exchanger adsorb the H plus ions and anion exchanger adsorb the OH minus ions, because cation means it has a capability of absorbing positive ions, that is a H plus ion, and anions means negatively charged, therefore it has the ability to adsorb OH minus ions. And the cation exchange resins are first treated with dilute acid. Then the cation exchange resins, because they contain H plus ions, they are treated with the dilute acid, and the H plus ions of the acid get adsorbed by the resins because it contains the dilute acid. Therefore, the H plus ions of the resin of the acid can be adsorbed by the resins. And the anion exchange resins are treated with the dilute alkali because it contains the OH minus, that is an alkali. Therefore, it can be treated with dilute alkali. Therefore, what happens? The OH minus ions of alkali get adsorbed by these resins, and the cation exchange resins and anion exchange resins are then washed several times to remove excess of acid or alkali. Means if we are using acid for the removal of H plus ions, then or OH minus or base for the removal of OH minus ions, they both are washed with these cation exchange resins, and anion exchange resins are both are washed several times to remove the excess of acid or base or alkali present in the solution. And these are processed cations. These processed cations and anion exchange resins are further used to remove calcium, magnesium, chloride and sulfate ions from the hard water. If some calcium, magnesium and chloride and sulfide ions are remain in the solution, so these processed cations and anion exchange resins are used to remove these all ions. And when the ions like calcium 2 plus, magnesium 2 plus from the hard water come in contact with the cation exchange resins, means these two ions, calcium 2 plus and magnesium 2 plus, when come in contact with the cation exchange resins, the H plus ions get exchanged for Cl minus or SO4 2 minus ions. Means the H plus ions from the cation exchange resins, they can be exchanged for the Cl minus and SO4 2 minus ions. Therefore, the Cl minus or SO4 2 minus get adsorbed by the resins and the water is softened, because water mainly contains calcium, magnesium, chloride and sulfide. And if the cation exchange resins that is containing H plus ion which adsorb the Cl minus and SO4 2 minus, they are removed from the water. Therefore, the hardness of water is decreases and the water get softened. And this is called as a demineralized water, because the minerals that are present in the water, that is the chloride, sulfate, these are minerals, they are removed by the H plus ions from the cation exchange resins. Therefore, the process is called as a demineralized. The process by which the water is formed is called as a demineralized water. So, in this way, the purification of water is done by the cation exchange resins and anion exchange resins. So, next and third application is the production of high vacuum. So, what is the production of high vacuum means? So, we have seen that earlier, as in earlier, gases are more readily adsorbed on the solids at low temperature. Means the gases get easily adsorbed on the solids at low temperature, and the considerable adsorption at low temperature and even at a low pressure is utilized for the production of high vacuum, because in some reactions we need the condition that is a high vacuum. So for this, the production of high vacuum is done by using the adsorption process. The coconut charcoal is cooled in liquid air is a efficient adsorbent. Means the coconut charcoal which is cooled in liquid air, which acts as an efficient adsorbent, and it is connected to the apparatus which has already been first evacuated as far as possible by vacuum pump. Means this is connected with the apparatus which is first evacuated by the vacuum pump, and the charcoal adsorbs the remaining gases and moisture almost completely, and thus creates the vacuum, high vacuum. Means the role of coconut charcoal is that firstly the apparatus is evacuated, but by using the coconut charcoal, the remaining gases which are present can be easily removed, and also the moisture which can completely removed by this coconut charcoal, and thus it creates the high vacuum, and which is most important condition for the some organic reaction. So this is also the most important application for the adsorption material, that is a production of a high vacuum. So fourth application, that is a chromatography. So we know that what is the chromatography? The chromatography is the method to separate the constituents of a mixture. Means chromatography means by this method we separate the constituents of a mixture, and it is based on the fact that substances can be selectively adsorbed from the solution by given adsorbent. Means the chromatography technique is based on the fact that some substances can be selectively adsorbed from the solution by the given adsorbent, and in the analysis a solution of mixture in a suitable adsorb from the solution by a given adsorbent. Means the solution of mixture a suitable adsorb solution by the given adsorbent. And in the analysis a solution mixture in a suitable solvent means the solution mixture which we have to separate, which is dissolved in a suitable solvent such as acetone, benzene or alcohol, and is allowed to flow through a long tube. Means in the chromatographic technique we used a long tube that is called as a chromatographic column. So it is allowed to flow through a long tube, that solution, and fill with the adsorbing solid. Means in the it is consist of burette like column. In the laboratory we also do the experiment. In that column that column is filled with the adsorbing solid, and in that column we insert the solution of mixture of a suitable solution of a mixture which is dissolved in a suitable solvent. The solvents used are acetone, benzene and alcohol, and it is then that solution which we have to analyze or which we have to separate is then passed through that long tube, and which contains the adsorbing solid. And after passing the mixture through the adsorbing solids, so what happened? It is observed that the upper layer consists of mainly the solute, and that is more readily absorbed by the adsorbent together with small amount of less readily adsorbed solute. Means when we pass the solution which we have to analyze from the chromatographic column, so the upper layer it consists of the solute which is most readily adsorbed. Means in the upper layer the solute which is most readily adsorbed is present in the upper layer, and it also contains the small amount of less readily adsorbed solute, and the less readily adsorbed solute gradually passes through the adsorbed column through lower down. Means more readily substance is present at the upper side of the column, and less readily substance get passed gradually through lower down of the column as they pass through the column. Means simply the most readily soluble compound is present at the upper side of the column, and least readily soluble is present at the lower side of the column. So some amount of pure solvent is allowed to pass slowly through the column. Means after the passing through the solution or mixture which we have to analyze, some amount of pure solvent, if acetone is used, acetone or chloroform, that solvent is allowed to flow through the column, and the less readily adsorbed solute are removed from the upper parts of the column, and the successive layers of the column contain other constituents and ease of adsorption. So when the separation is completed, means by using the flow of solvent, the less readily soluble and more readily soluble can be easily removed. And when this separation is completed, the adsorbent column is pushed out of the tube and cut into section. Means it is cut into section. So why we have to cut into section? Because we have to separate the fractions that we have separated by the chromatographic technique. So the adsorbed constituents from the section is then dissolved by using suitable solvent, and alternatively the large amount of solvent is allowed to pass through the column. Means again the large amount of solvent is allowed to pass through a column, and less strongly adsorbed substance will be pushed down the column and collected at the bottom first. Means the substance which are less strongly bound, they push down to the column because of a large amount of solvent. So it is collected at the bottom first, and the other constituent in order of ease of adsorption are collected successively at the bottom. Means by successively the flowing the solvent, the other constituents get collected at the bottom. And the selective adsorption or differential adsorption is also responsible for separation of gas constituents from their mixture with the help of gas solid or gas liquid chromatography. Means the selective adsorption or Differential adsorption is also responsible for the separation of gas constituents from their mixture with the help of gas solid or gas liquid chromatography. Means in the gas solid chromatography, these two phases are used. One is the gas phase and other is a solid, that is a solid adsorbent. And in the gas liquid chromatography, one phase is a gas phase and other is a liquid adsorbent is used. So this is the technique, that is a chromatographic technique for the separation of solvents. So the main aim of the chromatographic technique is to separate the constituents of a mixture from the solution. So in this lecture we have studied the three applications. So we will summarize that three application. The second application we have studied, that is a purification of water. So in the purification of water we use the cation exchange resins and anion exchange resins. So the H plus and OH minus ions can remove the cation SO4 minus and chloride ions. Therefore the softness of water is increases, and due to all the minerals are removed from the water is called as a demineralized water. Thus in this way purification of water is done. Next application we have studied, that is the production of high vacuum. So production of high vacuum. So in the some organic reactions the condition is required, that is a high vacuum, which is created by using adsorbent material. In that we have studied the coconut charcoal is used as an adsorbent to remove the some moisture or some gases that are present in a mixture in which we have to carry out our reaction. And the last application we have studied, that is a chromatography, and in that chromatography we have studied that for what technique is used, for what the chromatography is used to separate the components of a mixture by using column. So there are mainly two types of chromatography, gas liquid or gas solid chromatography. So thank you. In the next lecture we will study the last two applications of a last three applications of a adsorption, that is a adsorption indicators, as a adsorption indicators in the determination of surface area and some other application. So in this way we will end our second chapter. So thank you.